Hey everybody, this is Mr. Munson, and we are in Unit 7, Right Triangles. This section, 7.2, is Special Triangles. If you take a look at your student learning map, you'll see we have several I can statements that you'll need to be able to accomplish by the time you get through this video. All right, two special triangles that we're going to learn is the 30, 60, 90 triangle and the 45, 45, 90 triangle. Let's get started. All right, so what we're going to be doing is we're going to be operating under the assumption that you understand similar triangles. That's from the last unit. And here's the deal. I'm going to need you to remember this 30, 60, 90 triangle and the specific sides that I'm giving you. Okay, so we have a 1, a 2, and a square root of 3 that belong on this triangle. Now, we've talked about this before. Across from the largest side is the largest angle and vice versa. 2 is actually the largest side. Now, I remember these sides by going 1, 2, and it makes sense to say 3, but it's not. It's going to be 1, 2, square root 3, and it's almost like lyrics of a song. I just have it all the time. 1, 2, square root 3. You'll hear me say it over and over in class exactly that same way. I encourage you to say it out loud and just memorize it. All right, so 1 is the smallest side, so it's going to go across from the 30. 2 is the largest side. It's going to go across from the 90, and square root of 3 goes across from the 60. Okay, so what we're going to do is we're going to use that basic triangle, that special triangle, to work triangles when we come into them and we say, hey, find these missing sides. You can see there's only one side given, so I can't use Pythagorean theorem, which is what I would normally do if I'm given two sides of a triangle. I'd find the third one by Pythagorean theorem. Hint, remember that for your do-it problems at the end of the video. So what we're going to do is we're going to take this 30, 60, 90 triangle and bring it into this problem on our own. So when you see this in the future, you automatically do that. You put in the sides, and then we'll write proportions. Let me show you what I mean. So we've kind of zoomed in a little bit. So the very first thing I'm going to do is I'm going to write down my sides. 1, 2, square root 3. I do it the same way every single time. One-step process. I'm not trying to draw the triangle and put the sides in. I do that first. Then I draw the triangle, and if you notice, I draw the triangle in respect of the same way it is drawn over there with the 60 in the same place, however they draw it, okay? All right, so then I take the 1, 2, square root 3, and I put them in order. 1 across from the 30. It always is the first one I put down. Then I go to the hypotenuse, I put down the 2, and then across from 60 it has to be the square root of 3. Okay, so now if you look at it, I have two triangles that are similar. I know that by angle-angle similarity. That means their sides are proportional. Did you hear it in your brain? If you did, that's how your brain works, and that's why I've been doing it. All right, so what I'm going to do is I'm going to write some proportions, right? I know that to find the missing sides, I can just simply write proportions. So if you take a look, I have 5 over 1. Right? 5 over 1 is equal to x over 2. Now, I'm not going to cross multiply and solve that. It's a simple problem, right? Let's go find y. So let's write that one. 5 over 1, might as well use the same fraction. I got both numbers there. And so my unknown is going to be on the other side. So 5 over 1 is y over square roots of 3. It just matches up. They're corresponding. Okay? They're across from the same angle, so I know that to be the case. Simple as that. Cross multiply, and you get 5 square roots of 3. Now, just one of the things I want to point out is that I always put the number out in front and the radical net last. That's the way you always do it, okay? If you ever do this or this, I'm not going to like that, okay? The reason is because this kind of looks like the square root of 35 and the square root of 3x. That's just a standard. You always put the radical last. All right. All right, so go ahead and put me on pause and see if you can do this one, okay? Do it in the same order. Write down the three sides in order, 1, 2, square root 3. Draw a triangle that is in reference to that one, perfectly drawn. And then bring in those sides to the correct place, start writing proportions, and solve. Put me on pause and come back and check your work. Okay, so hopefully you wouldn't be surprised that I write down my sides, then I draw my triangle. My triangle's drawn exactly like the other one, okay? 30's in the same spot and everything, okay? So now the triangle's flipped around, so I'm going to take the 1, and I'm going to find the 30, and I'm just going to go right over to where the 30 is and put the 1 there across from the 30, right? Then the 2 gets placed down, and then the square root of 3. That's how I do it, okay? Everybody good? All right. Next thing I'm going to do is I'm going to now start being able to write proportions. So I look for what I can do. So let's go find y first. And so I'm going to say 4 square roots of 3, right? This 4 square roots of 3 over its partner, square root of 3, is equal to y over 1. Okay, no big deal. So I cross multiply. I need to get that y by itself. So I'm going to divide both sides by square root of 3. If I can get it in here. Yep. Divide both sides by square root of 3. There we go. And that, of course, cancels out that square root of 3 in this case. And it cancels it out over here. And that leaves me with y equals 4. Okay? So now I know y is equal to 4. Let me not do it that way. Let's do it this way. Got y equals 4. Now let's do x. So go ahead and put me on pause and see if you can write your proportion and everything for x. If you've already done that, excellent. Let's do it together then. Here we go. Okay, so when I cross multiply, I get that. I always try to put my x on the left-hand side, right? Remember, always take your x or your radical and put it last, right? So I have x times square root of 3. All right, so then divide both sides by square root of 3 and they cancel each other out. And that leaves me with x equals 8. Now, just for those people who might be getting this at a really high degree, I want to show you something kind of cool. This is no surprise to me that this is equal to 4. Okay? Here's the reason why. If you take a look at my reference triangle, the side that goes with this 4 square roots of 3, you can see that this side right here, 4 square roots of 3, is 4 times bigger than the square root of 3. That means every side is 4 times bigger. That means 4 times 1, which gives me 4, and 4 times 2, which is 8. Okay? Now, it's not always that simple, but you can start seeing that kind of pattern, and it makes it a little bit simpler for it. For now, on your work, to get credit, you're going to have to show me proportions. That's what I'm going to be looking for to give you credit. Now let's take a look at this problem. This is the second special triangle that I need you to memorize. And the way you're going to memorize this is you're just going to say the sides are 1, 1, square root of 2. So these are the two congruent sides, and of course they're congruent because they're across from the 45s, right? And you have square root of 2 on the hypotenuse. So you need to memorize that triangle and the sides, those special sides, so that when you walk into a problem like this one, where again you're not given but one side, you can't use Pythagorean theorem. You're going to have to look for something else, and it's going to be this 45. So as soon as I see a 45-degree angle, I know it's a special triangle problem. As soon as I see a 30, I know it's a special triangle problem. All right? All right, so let me zoom in. We'll work these problems. We'll do one together, and then I'm going to expect you to do the other one on your own. Okay, the first thing I'm going to do is I'm going to write down my sides, right? 1, 1, square root of 2. Then I'm going to draw my reference triangle to be just like the other one. Okay, now these triangles are not congruent in any way, but they're similar because they both have two angles that match up, angle similarity, right? Okay, so I have the 1, 1, square root of 2 on the green triangle, right? So now I have two similar triangles, and that means that their sides are exactly proportional. Now, finding x is going to be quite easy. To find x, I just know it's 17, and the reason why is because across from those two angles, now the other angle is 45, right? Across from congruent angles are congruent sides. So I just know that those two are 17. That's easy enough. Why? It's going to take a little bit more time. Okay? So just write a proportion. 17, the left one to the right one, 17 over 1, is equal to y over square roots of 2, right? I'm going to cross multiply. And then y equals 17 square roots of 2. There's your answer. All right, see if you can have a go at this one. Again, do this one on your own so that you can own how to do this. This is not hard. Don't be scared of this stuff. All right, go ahead and put me on pause. Draw your reference triangle first. Write down the three sides first. Just get used to doing that. Maybe even speak it out loud. 1, 1, square roots of 2. Draw your reference triangle just like the triangle here, and then put the sides into the correct place. Then start writing proportions. It's that simple. Go ahead and put me on pause now. All right, so there's my reference triangle, and again, it's matched up with the one that's above it. Put the sides in the right place. Let's start finding x. I got 15 square roots of 2 over square roots of 2 is equal to x over 1. cross multiply. Whoops, sorry. Cross multiply, and I get that. I'll divide both sides by square root of 2. That cancels that one guy out, right? And on the other side, it's going to cancel it out there as well. I'm left with x equals 15. Okay, so I know x is 15. That means y is 15. I'm done with this deal. Okay. All right, very good. Now again, this, just like the 3069, this was very predictable. Okay, if you look at this, here's 15 times square root 2. This reference triangle, which has a square root 2, this triangle here, if you multiply it times 15, you get 15 square root 2. So it's, every side is 15 times bigger. Okay, not every problem comes out that way. We'll do a couple of a little bit more challenging problems that that's not so easy to see. Again, I want you to write your proportions. You're going to need to do that to get credit, and then we can start looking at some tricks. Let's move on. Okay, listen up. This is a bonus. So on another piece of paper, you're going to write bonus 7.2, right? So I know where you got it from. And I want you to see if you can figure out what x and y are in this. It's really not that hard to do, okay? You just need to realize that it's two different problems, two different triangles. One is a 30, 60, 90 triangle, so maybe draw that and the sides that and the information that goes with it. And the second one is the 45, 45 triangle, right? And so you put the information with that. Set up these two separate problems, bring in your reference triangle, solve for the missing sides. Doing awesome. All right. Okay, here's your do it problems. And so I'm going to obviously zoom in so you can see them a little bit better. Keep in mind that number 3 is a review question. Number 5 or number 4 is a review question. Go back and find those if you're not sure how to do them. Okay. Show your work. Make sure that you're using proportions. I need to see your equations for these two. Circle your answers. Don't forget to put your name and date on it now, so I'm not standing there waiting for you to turn in your homework while you're putting in your date. All right, very good. You've done an awesome job to get this far. Let's keep on going. End of lesson. Here, I'll scroll into it so you can see them a little bit bigger. If you're viewing it on a small screen. Very good. Take care.